Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and welcome to the podcast known as Space Nuts. My name's Andrew Dunkley, and with me as always from the Australian Astronomical Observatory, one Fred Watson. There is only one. Hello, Fred.
Well, there's the other one as well, but I once got an email actually from a guy called Fred Watson, and I thought I've just made a mistake and sent this to myself, so I ignored it for a fortnight. But he was trying to contact all the Fred Watsons on the internet. It was from the USA. I thought things
that's a heck of a project. yeah, get a life indeed. But good morning if you're listening, Fred Watson. It's not the Fred
exactly.
Watson we're talking to.
I was just thinking the same thing myself. Sorry, Fred. It's okay. Actually, if you're listening to Space Nuts, get a life.
Fred made a joke. Now, today, Fred, we're going to talk about, this fascinates me because we've talked about sending missions to ice moons and ice planets before and looking for life. Well, now somebody wants to do it, and this could be a private venture, which is fabulous if they can pull it off, and light pollution. Now, you and I have talked about light pollution in the past and what a problem it is for astronomy, but now, because of technology and the advances in lighting, we are facing bigger problems with light pollution on the planet than ever before. We'll talk about that, and we will answer a question from the studio audience, and that is whether or not we can derive energy from gravitational waves. What a great question. We'll get to that very, very soon, thanks to Dr. Rob Scott from Queensland. So, Rob, listen in. Your answer coming up soon. But first, Fred, this private mission to get to Enceladus and see if there's anything lurking under the surface. Wouldn't that be exciting?
Would it not? And this story comes on the back, I think, of the Cassini mission, which, as you know, came to an end on the 15th of September when the Cassini spacecraft plunged into the upper atmosphere of Saturn, melted and became part of Saturn's atmosphere, which I think is highly poetic. The spacecraft, of course, made many, many discoveries, perhaps the most exciting of which was that Saturn's moon Enceladus, whose structure we know is a rocky core overlain with a global ocean of water, salty water, which itself is overlain by an ice layer. The spacecraft flew through plumes of ice crystals, these fountains of ice crystals which erupt from the subsurface ocean round about Enceladus's south pole. And many discoveries were made by those flights through the ice plumes, including the fact that, first of all, yes, these crystals are ice crystals. Secondly, they contain nanoparticles of silicates, and silicates are just bits of rock. Yeah. These tell you not only that ocean has a seabed which is in contact with rock, but also that rock is almost certainly places where hydrothermal activity occurs. And by that I mean these things that we have on the floor of our deep oceans on Earth, these black and white smokers, which are essentially flows of warmed water, which have seeped through into the rock deep down underneath the ocean floor, been heated by the Earth's mantle, which is not far below that, and then spurted back up. And these places are thought to be one of the possible sites of the origin of life on Earth. So the equation is this, that we know from those silicates and also from the detection of something called molecular hydrogen by Cassini, we know that hydrothermal vents exist on the surface, the ocean floor of Enceladus. Get it right, Fred. Quick, you're on Space Nuts. On the ocean floor of Enceladus. And so we know that. Also, we know that we get free samples of what that ocean water is like and what it might contain, because we've got these plumes of ice that are being erupted from there. So you put those two together, and what's happened from that is the idea of space missions dedicated to Enceladus. And there are at least 3 which are being planned by NASA and ESA. NASA, of course, needs no introduction. ESA, the European Space Agency. And they've all got delightful names, actually. The one I like is ELF. ELF is the Enceladus Life Finder. This is a spacecraft whose particle detectors and mass spectrometers and other equipment is tuned to look for things like amino acids and proteins, which were not detectable by Cassini, because Cassini wasn't set up to do that. It was set up to look for minerals and things of that sort, all of which it did most successfully. But nobody ever thought that we'd go to a place where we could look for proteins and amino acids and lipids and things of that sort. So ELF is one. The other one I like is Selfie. And Selfie is the submillimeter Enceladus Life Fundamentals instrument. And what this is a device that will pick up the submillimeter signature of molecules. You and I have talked about this kind of thing before, because ALMA, which is a telescope in the high Atacama Desert in northern Chile, is a submillimeter wave telescope, and it's been probing the atmospheres of other stars and things like that, and finding molecules which themselves are very suggestive, carbon-containing molecules. Now, you can do the same thing, but not from Earth and not pointing at a distant star. You can do it from a spacecraft that is in the vicinity of these ice plumes, and you can look for the molecular structure that's in the ice plumes, and maybe you could find the same sorts of things, like amino acids and other building blocks of life. And there's one more. The Europeans are planning one called E2T, which is Enceladus to Titan, and it's a mission that would take in both those worlds, because Titan's another place where maybe life has taken hold. Anyway, that's the backstory,
yes,
Andrew.
Yes.
Oh, we've finished.
And that's
we've
all
run
got
out of
time for this week.
Oh, what a shame. So that's the backstory. But of course, these missions, they're NASA and ESA missions. They cost probably in the region of $1 billion, maybe more dollars. They will probably have a preparation time of 7, 8, 9, 10 years or something like that, maybe a flight time of 3, 4, 5 years to get to Saturn. It's a long, long process.
You've got to be patient.
So you've got to be patient, unless your name is Yuri Milner.
Yes.
And Yuri Milner is this Russian billionaire who's already funded what's called the Breakthrough Initiatives project. And that's a set of 4 projects, the most prominent of which is Breakthrough Listen, which is given $100 million to, which uses time on 2 major radio telescopes. One is the Parkes radio telescope here in New South Wales, to listen for signals from extraterrestrial intelligences. So he's funded that. He's funded something called Breakthrough Starshot, which is basically a design study for a flotilla of micro spacecraft, which would be beamed on a laser beam towards Proxima Centauri, the nearest star to us, 4.2 light years away, which we know has a planet around it, at least one planet around it. But what he's saying is, wait a minute, I've got a lot of money. Maybe, just maybe, and he floated this in a recent conference, maybe there's a way of fast-tracking this project to do a sort of quick and dirty recce around these plumes by sending a dedicated spacecraft, probably using, SpaceX hardware, things of that sort, to get to Saturn quickly, to have a quick look, see if we see any signs of amino acids, proteins, lipids, all the rest of it, and then let the NASA and ESA projects do the real heavy lifting in terms of the details of what we might find there. It's a really interesting proposal. My guess is, and this is, forgive me, Yuri, if you're listening to this, my guess is that he hasn't got enough money. Oh. But he's clearly a person who can engage other funding agencies. It may well be he's a bit like Colin Pillinger, who was that British scientist who gathered funding to send Beagle 2, his spacecraft to Mars, which we've talked about many times. I think he's that kind of person. If he can do that, well, just maybe this might work. And what's really great about it, Andrew, is if he does it quickly enough, we'll be able to talk about it on Space Nuts.
Yeah. We might be able to break the news that there is life beneath the icy surface of Enceladus. Let me just throw a curveball here at you, Fred, and I know you'll have questions without notice. But let's assume all these missions get there and are successful in doing what they need to do to search for signs of life. What would be the odds of a discovery?
Yes, that is a curveball question. It's one that you're entitled to ask, and it's one to which no one in the universe has the answer. Well, somebody in the universe might have the answer, especially if there are advanced organisms beneath the soil, the seas of, or the ice of Enceladus. We don't know, and that's partly because the actual processes, the chemical processes which lead to that transition between a prebiotic chemical situation where you've got molecules reacting with one another and something that you can call life, which of course involves all kinds of things like metabolism, things like the possibility of self-replication, things like the possibility of a Darwinian evolution if you leave these things to their own devices, to the survival of the fittest things. These are the kinds of things that people point to as distinguishing life from mere chemistry. But nobody knows just how difficult that transition is. The feeling, I have to say, in the world of astrobiology is that it is a fairly straightforward transition. And if you've got the right chemicals, you will get the right living organisms. There'll probably be microbes. You need long chain molecules that can form cell walls to contain these reactions within the body within a cell, rather than just have them in an ocean floating around and trying to react with the next molecule, which might be a mile away or something like that. Yeah. So it's the thinking is very positive, very optimistic in terms of the origin of single-celled molecules. The next step to get from single-celled organisms, I beg your pardon, optimism about single-celled organisms, less optimism about multi-celled organisms, how common they might be.
Although the thinking is, in terms of single-celled organisms, that as you and I discussed not so long ago, there may well be a lot more of this in the universe than we've ever considered. So this trip to Enceladus could well be the first, could result in the first major discovery. Let's hope so. I think it'd be exciting.
Absolutely. I think it's a great idea, and good on you.
And of course, being human beings, we will send invasion forces and deal with the problem promptly.
Of course.
Okay, more to come on that. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree, and governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now we're going to talk about a new problem that has become very apparent in the world, and that is light pollution. Now, light pollution's been a problem for a long time, particularly for astronomers. But now it's becoming a problem for humanity. And the reason is that the world is getting brighter. And Fred, the reason it's getting brighter is because we've become technologically advanced and we're using different kinds of lighting.
Absolutely right. And of course, excuse me, light pollution is one of the things that I spend a lot of my time thinking about, because it's an important part of my job with the Australian Astronomical Observatory to keep our skies dark. The skies above the telescopes at Siding Spring Observatory in northwestern New South Wales, Australia, they are pristine. They are as dark as they were 50 or 60,000 years ago when the first people started looking at the sky from that place. It's different, though, when you look at the horizon. We've got blobs of light on the horizon that come from things like coal fields. They come from cities. We can actually see the lights of Sydney on our horizon, even though it's about 350 kilometres away, line of sight. So that's all very much part of my job. And of course, very much the focus of an astronomer. And it has to be said that the current growing awareness of the ills of light pollution really had its origins in the world of astronomy, back actually in the 1980s, 70s and 80s, when astronomers, principally in places like Arizona, where there are big telescopes, California, where there are big telescopes, where astronomers realized that they were losing the night sky because of the encroachment of cities and the amount of light that was there. And that led to something called the International Dark Sky Association, which is the principal advocacy body for dark skies.
And a good example of it is when you stand in the middle of a major metropolitan centre. And I did actually test this when I was in New York. I looked up. I wanted to see the stars, and there was nothing.
Yeah, that's right.
Because of the light pollution. It just blocks everything out. It's a staggering effect.
Indeed, and New York's a particularly interesting case because it's probably about a couple of years ago, they had major power blackouts, and people could see the Milky Way and stars. And, basically radio stations and TV stations were getting calls from worried listeners and viewers saying, "What's all that stuff in the sky? We don't know what that is. There's stuff invading us."
Yeah. And I've spoken to people who've come to the country from Sydney for the first time, and they just go, "The sky is amazing at night."
Yes.
Well, to us, it's just normal.
It's normal, that's right. So there's a little bit more to say about this, and I might just mention, before we talk about the details, that the issue of light pollution is now widely recognized as being so much more than just astronomers. It affects all living species on Earth that are in urban environments or places near places where there's a lot of light. Things like crop pollination is being threatened because we realize now that if you've got artificial light, the insects that normally do the pollination don't like it, and they either go away or they die or they basically just stop. Trees in brightly lit areas actually going to bud in springtime up to a week earlier than they do in darker areas. It's clearly affecting their circadian cycle. And we've known for a long time that something like 2 billion birds a year get wiped out just because of New York State. The lights there, these are migrating birds. They head off looking for whatever they're looking for, come across a city, and they either crash into buildings or they just fly around them in orbit until they drop because they're lost. Yeah, terrible stuff. Yeah.
And it was only recently they figured out that was the problem. Up until some years ago, they had no idea why this was happening.
Yes, exactly. So, and two other ways that it affects perhaps the dominant species on Earth, ourselves. We now know that light that's rich in blue, and that's, light that comes from a really white source. It's got richness in blue light there. That is really bad for us in terms of disrupting our circadian rhythms, which are vitally important. We've evolved these over hundreds of thousands of years, and we've evolved in an environment that gets dark at night and bright during the day, and our systems are all set up for that with very little room for tinkering around, which is what we're now doing. And there's been, we've seen that some of these disruptions actually lead to very serious illnesses, to the extent that last year the American Medical Association actually designated something called the detrimental effect of poorly designed high-intensity LED lighting. And LEDs, of course, light-emitting diodes, are what we are now seeing being rolled out across the world for urban lighting, as well as in our own homes, and as well as on the headlights of our cars and all the rest of it.
And they are significantly brighter. They are, and they're cheaper to run. They don't use as much energy, and they last a heck of a lot longer. You can't blame people for using going this way, but we are now starting to see the effect of that, and it's not good.
That's right. And just one postscript about LEDs. In many ways, I think the technology has been rolled out too early. And the reason is that these days, to get a high, it's not quite true now because the technology is moving on. But if you look back a few years when a lot of this rollout was taking place, 2 or 3 years, the high intensity LEDs that were used, to get the highest efficiency, you give them a lot of blue light. So they are very rich in blue light, the high efficiency LEDs. They're cheap to run, but they're very bad for us. And not only that, actually, they're bad for the environment because blue light is the one that spreads around much more readily than red light. So that's the background. And what we now have is a kind of global map, which has come from a US spacecraft. It is one that's been surveying the Earth for many, many years. It's called Suomi NPP. It's a weather satellite, and it's got an instrument on board it which actually looks down at the Earth and basically just measures the brightness of what it's seeing beneath. And what's happened is over the last decade, there has been a 2% over the last 5 years, there's been a 2% per year increase in the brightness of the Earth.
That's amazing.
So over that short time. And this is a surprise to the scientists who've carried out this work. And the reason it's a surprise is because of what we've just been talking about, this rollout of LEDs, which have got very high efficiency in the blue, they should have made the world look bluer. And it turns out that Suomi, the spacecraft, is not sensitive to blue light. And so what they expected to see was a reduction in the amount of light coming from the Earth, because the Suomi spacecraft is sensitive to light that's sort of more red than kind of greeny orange. But it doesn't see the blue. It just sees the orange, the green, the orange, and the red colours of the spectrum, and a little bit into the infrared. And so they expected that those kind of lights, like the sodium lights, the old yellow street lights that we're all familiar with, they're being phased out. They expected that would produce a reduction in the amount of light that Suomi sees, because the blue light is not sensitive to the blue light, and all our street lighting is now a bluer in colour. But they're surprised to see, no, it's increasing across the board. And what that tells you is that LEDs are so successful in terms of providing cheap lighting that lighting authorities have said, oh, well, we'll just put more lighting in.
Exactly right, yeah.
We can run more lights for the same price.
Yeah.
And so the whole world is getting brighter. There are a few places that aren't. They are the war zones of the world. Syria is one. I sometimes in my talk show a comparison between Syria in 2016 and Syria in 2012, and it's heartbreaking to watch because you see all these cities literally disappearing. Hopefully that will change sometime soon. But we don't want it to get brighter, but we do want people to, to have rather better quality of life than has been the case recently. Yeah. So the outdoor lighting issue, I think, is one that really needs to be addressed. We find that there's been a very rapid increase, particularly in countries where up till now there's been no lighting, like northern India, for example. We've got villages there that haven't had electricity. Now with LEDs and cheap electricity, they can be illuminated. But sadly, the lighting engineering world has not caught up with the fact that it's very easy to make lights night sky friendly, and that is by fully shading them. You shade them so that no direct light goes upwards. But unfortunately, a lot of light fittings, even the ones designed today in our highly informed environment, even the ones designed today, throw a lot of light up into the sky, and that's where it does the damage. That's where it stops you seeing the stars and affects migrating birds and all the rest of it.
Yeah, and like a few years ago, they were very concerned about people using mobile devices, mobile phones and tablets and things like that, because they emit blue light. And I got a new phone recently, and I was surprised to find that it had a setting on it to increase the red light so that I didn't get affected by the blue light and stay awake at night. And I even was able to set the phone so that it would switch to the red light mode at a certain time every night, so I didn't even have to think about it. Fascinating. So, there are solutions. Looking at the photo of the Middle East, and I'm looking at the River Nile, I mean, it is most amazing the amount of light in that small part of the world, stretching right up the length of the Nile River. And right next to it is the Red Sea, and it's black because it's the Red Sea and there's red light. Terrible joke. But it is a huge problem, and one that people are going to have to seriously consider into the future, or we're going to have even more problems on a global scale. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
Finally, Fred, we have a question to answer. That's very rare. Hey boys, great show. Another question. Could we ever derive energy from gravitational waves? That's a really good question from Dr. Rob Scott of Buderim in Queensland. Well, we only recently talked at length about gravitational waves and the fact that they were discovered, but would it be possible to derive energy from them?
I think the answer to this is you can never say never.
But at this point in time...
But even at this point in time, you can never say never. But it seems pretty unlikely. Just to recap, so gravitational waves are basically waves that are spread by... Let me start that again. Gravitational waves are waves that spread through space by vibration of space itself. And that's because, as Einstein showed back in 1915, space is flexible. It can move, it can bend, and that's totally counterintuitive. But it is correct. The only thing is, whilst it's true that space can bend, compared with anything we know about on Earth, hard materials like steel and things of that sort, space is far, far more rigid than those things. It can bend, but it needs a lot more force. And in fact, what bends it is gravitation, exactly as Rob has said. Gravitation is the process. Objects like the Earth have gravitation. It's a property of matter itself, and that gravitation we experience by basically feeling the distortion of space that is the result of a world like the Earth being dumped in the middle of space. It distorts the space around it. We feel that as gravity.
Yeah, we feel it in our everyday lives. Right now I'm sitting down and I can feel pressure on my posterior.
Indeed.
That's gravity.
It's gravity, that's right. It's very, it's tempting to imagine it as Newton did, as a force. And basically that's what we all do. We imagine it as a force pulling us down. But it is this distortion. It's the fact that space at your feet is a slightly different shape from the space at your head, and you feel that pull as gravity. But it's not even microscopically different. It's way, way below that, the difference in shape of space. It's nevertheless detectable, and in fact you can put spacecraft into orbit around the Earth that can actually sense the change in gravity as they go from one part of the orbit to another. Okay, so Einstein also predicted that if you have large masses being accelerated in the universe, they will produce waves. They'll disturb the space around them to the extent that ripples will spread out through space itself. And that's what we call gravitational waves. And as you correctly said, it's only within the last couple of years that we've been able to detect them. There are now two instruments that can do that. There's one called LIGO, which itself consists of two gravitational detectors, and another one in Italy called Virgo. And together they make effectively a crude gravitational wave telescope, and that's how we've discovered something like, I think it's 3 sets of colliding black holes and 1 set of colliding neutron stars, and that's very exciting. That was the recent discovery that was announced a couple of months ago. So we've got these waves that come to us through space. They affect the Earth, and that's how we can detect them, because this detection is done by bouncing laser beams off mirrors, and it's the movement of those mirrors that reveals the presence of the gravitational waves. But the kind of movement that the mirrors experience is not great. In fact, they reckon that they detect something like 1/10,000th of the diameter of a proton in the movement of these mirrors. It's just mind-blowing.
Yeah.
It's such a tiny movement. It is almost impossible to imagine it. And that's what you get from colliding neutron stars 130 million light years away. You get this tiny vibration, which lasted for 90 seconds. The ones that we saw from the neutron stars. So it's a very short-lived thing. So the amount of energy contained in that is extremely small. Of course, the amount of energy that caused it is huge, because those neutron stars effectively burned up the energy equivalent of something of the mass of the sun to cause those gravitational waves. But as they ripple through space, they lose their energy. Actually, not quite like light. They're different from light, which loses energy proportional to the square of the distance. It's just proportional to the distance with gravitational waves. And so, if we had
I actually understood that, believe it or not.
Oh, good. I'm glad to hear it. Good. Thank you.
Don't ask me to explain it back.
we aim to please. So I think anything that was going to give enough gravitational energy for us to harvest it would actually be very dangerous, because it would be wobbling space to the extent that who knows what the effect might be. You might find the Earth falls to bits or something like that if you've got that much energy going through, because you're talking about nearby events. So I think whilst harvesting energy from gravitational waves is a great notion, I suspect it won't happen.
Okay. There you go, Rob. It took us 6 minutes to say no.
I could have just said no, couldn't I?
It would have been a short episode. All right. And keep your questions and observations and links and ideas coming in. We love to hear from you. You can message us via Twitter, via Facebook, via bitesz.com. That's bitesz.com, which is our home planet. And any other way you want to get in touch with us, go for it. I've had a few people find me on Facebook and want to friend me. That's a first. But we do love to hear from you, so keep in touch. And thanks for listening. Our numbers in recent weeks have been staggering, and we really do appreciate that. Although I think last week Thanksgiving had a bit of a recoil effect, everybody recovering from their astronomical amounts of turkey. But I'm sure we'll be back on track this week. Thank you, Fred, as always. It's been a pleasure and great fun as always too.
Good to talk to you, Andrew, and we'll speak next time.
Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley, thank you once again for listening to us on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from bitesz.com.
And this episode of Space Nuts was brought to you by the Dollar Shave Club, a quality shave without the big price. Just visit dollarshaveclub.com/nuts so they know you came from us, and you'll get a special introductory deal. dollarshaveclub.com/nuts.